Welcome to the Barcoding Podcast. In this podcast, we like to share our knowledge as software developers, and we try to catch our Friday evening talks at the bar we have over software development or other topics. I'm Arnout Rijpkema.
And I'm Paulien van Alst.
And today we're going to talk about alternative JVM languages. Yeah, and every podcast series we start with just something that's always coming back, and that's a fun and inspiring fact we share. So, Paulien, what's your fun or inspiring fact?
I think maybe I've already mentioned it, but last week I've been working a bit on a domain-driven design side project. Why? Because we maybe want to refactor our system into such an application that's holding on to those principles of domain-driven design, and then especially also all the event processing part. And I always really think it's an interesting design pattern to set up your application and stuff like that. But somehow I never came to the point that I was writing a production application into something like that, and now it's might gonna happen. So I'm really enthusiastic about it to see how it's working out. But the most challenging part was actually to try to think out of a model. I was really I thought it would be very natural to write down a model, because you have to think about your events, about your commands, and events, that's just what's happening all day long, right? We have events all day long happening in our life, so modeling them shouldn't be very tough, but it's actually so difficult to think of the correct event, the correct naming and stuff like that. It was really challenging to dive into frameworks like Axon as well, that really guide you through how to model your application and how to set it up. I had to get the big blue book out of the out of my
Bookshelf?
Bookshelf again. Yeah, sorry, I forgot the word. And I was like, I'm picking it up, and this time it might happen. It might happen that I'm going to write an application with those principles written in this book, finally. And I think, I really like that, and I'm still wondering why we are not using that everywhere, actually. Maybe not with a very heavy framework like Axon around it, but even the most simple part about decoupling your various parts of your system, I don't really understand why we're doing that everywhere, because I find it really elegant. So maybe that's a new subject of a new episode if I figure that out.
I had the same idea while you were talking.
Yeah.
We should maybe if you're a little bit further along, we can share our knowledge.
Maybe, but I really like the concepts of domain-driven design, and I really want to apply them. And every time I see a speaker talking about it, I'm like, wow, this is a holy grail. And then you come back to work, and then it's actually a bit more harder than you think. So I'm really curious about to see the benefits actually to set up such a system. So that was my inspiring fact and eye-opening fact of the last period. What about you?
Cool. It was actually difficult to find one this time, and I decided to change it a little bit, not for work, and actually it doesn't matter. We can just share whatever we want. But for me, all the time we have Corona. We didn't mention it in the podcast because we thought we wanted to share other things than Corona. But what I find funny, in like, it's now 3 months on the way.
Yeah.
And in this time, when I'm watching TV, for instance, and somebody's shaking their hands, which is like, I'm used my whole life shaking hands with people, and now when I see it on television, I'm scared.
Yeah, it's like they're smoking, right?
Yeah,
like don't do that.
and that's, I think it's so crazy, and for me, it's inspiring that we can change in just a short time. People can change and learn other habits than they are used to, only if they want to. Because most of the time, when we fight against it, it's very hard. But now it's like we have to do it. But also, I think people can change a lot more things than they think they can, and pretty fast actually.
Yeah, because it's not really. I also had that reaction, but it was an unconscious reaction. So apparently, shaking hands and even keep your distances is something that really came into our minds in only 3 months. I had the same. It's really nice that you put it in those words, that we actually can change our mindset very fast if we want to. So, wow, I like this. It's not work related, but very relevant, I think.
Yeah, this podcast we are going to talk about alternative JVM languages. And maybe first it's good to talk a bit about what is the JVM, because what is alternative if you don't know the real thing. So I was looking into it, and it's actually a virtual machine, which is the last part of it.
Yeah, the VM.
Yeah, the VM, yeah. And it's a virtual machine just to run Java programs. So it's easy as that.
It's easy as that, right? Yeah. I was always also looking for a bit more elaborate definition, but I couldn't find one.
Yeah, nice. Yeah, and I think the main thing the virtual machine does is transfer Java bytecode to real producible commands to your CPU to do the calculations and other devices that you have connected, like GPUs and other stuff. Yeah. The JVM converts it from generic Java bytecode to just runnable things on your machine. And also one thing it would be good to point out that a JVM is OS specific in that way that you install one on your machine, which is architecture based. So you have difference for Mac, Linux, Windows, but the bytecode is the same. So
exactly.
You never recompile it if you change an architecture. You change from a JVM, which makes it way more easy to run your applications throughout every environment you want to run your application.
Yeah, actually that's one of the reasons why I wanted to program in Java. Because I found that principle very elegant, that you can just program against any OS actually, because it results to that. And I think that's a very strong part of Java, or the JVM. No, JVM actually. Let's be precise in this episode. Yeah, nice.
Yeah,
nice lookup.
Yeah, I think that's also the thing why I went for Java.
Yeah, really?
Yeah.
Oh, wow.
I really liked the same thing, that you can use the application throughout. Like every architecture, it's just one. Yeah, you make one program. I think it's really elegant and nice, and also easy to maintain it by. Like the sysops used to be, but also now I'm the sysops, hopefully, and that's also changing, and that's also why I like it. And also one thing to point out is that the JVM is a specification of the bytecode command. So it's also that will specify which bytecodes and commands can be used and which are run.
Okay, yeah.
So it's also a good specification you can find online if you want to. Yeah, so we can use the JVM just with Java, but also they develop some other languages. But Paulien, why do you think they developed alternative languages on the JVM?
That's a really good question, which I ask myself still a bit. Let's just first start about the day of your question. Who is actually inventing new languages? And I think there are various answers to that to the question. When I started working, Scala was one of the main alternative JVM languages a few years ago. At least I heard a lot about it. And when you have a look at Scala, it was developed at the University of Lausanne, École Polytechnique, and it was developed by a more mathematical department with a mathematical approach, which means more going into the functional programming paradigm, which wasn't supported in those days pre-Java 8 by Java. So it was actually designing a language that could support functional programming, which Java wasn't doing. So it was actually filling, or jumping into a gap that Java left behind. So that's one reason to do it. Just try to solve things as Java is not solving. Java is used by a lot of companies, so it has a huge responsibility towards the industry. It has to stay backwards compatible, which means that development still, even if they promise to go faster, still takes a long time, and sometimes the technologies around Java are evolving way quicker than Java can evolve itself. And that makes people want to think it all over again and invent another language. So that was for Scala, for instance, and then Scala became too powerful, too abstract, too difficult to maintain in production for the industry. So Kotlin came from the whole industry point of view. But before that, you already had Groovy as well, actually, to also trying to fill in some gaps. So that's one reason. Then you also have alternative languages like JPython and JRuby, which are implementations of other languages, but trying to run those languages on the JVM. So there it's answering another part of the needs, like running Python on a JVM, which is JPython. So there are a lot of answers to your questions. You can think of many reasons to invent another language for the JVM. You can write one yourself. There are also tutorials on the internet.
Oh, nice.
To do that. Maybe we can do JBar coding and then release that. See what we solve then.
Can all fix all our problems, hopefully.
Yeah, because Java isn't solving enough. I don't know.
That's true. I do agree with the point you gave that they sometimes fill in gaps in the language of Java. And also, and I think jumping on the easiness of the JVMs running on every environment.
Exactly.
And as a language, you don't have to solve those issues anymore because you can just generate Java bytecode and you don't have to worry about running it.
No, exactly. So that sometimes feels a bit awkward because those languages always want to compete with Java. They always want to say we are better, but they're using Java each time over again. So they are not really better. They just complement it and just propose a new flavor of Java. It's nothing more, actually. It's not a whole new language. It's not true. That's light. Because we're always compiling back to Java bytecode. Yeah.
Yeah, so we talked about the why, but and you also already mentioned some of the alternative languages.
I couldn't say.
It's no problem, and it's very cool actually that there are probably a lot more than you already mentioned.
Yeah,
so,
there's a long list.
So just Paulien, start with your first one, and then
So let's now elaborate on those languages. So first of all, I dived a bit into Java to know what is Java actually. Well, it's platform independent. We already stated that. It's fully object oriented. You can't really build an application in Java without using objects. It's not possible. You always need a class, which means you always have at least one object. And it's really hard to write code while avoiding objects. I tried sometimes in katas, but it's a very hard exercise. It's strongly really strongly statically typed. It means that a lot of it is checked compile time, so you're really safe with Java. Makes it very robust. It's platform independent. We already said it. And it's managing garbage collection for you, which I think a lot of Java programmers don't really are aware of.
No.
No, I learned to program in C++, and then you're handling your garbage collection all the way. So I'm still relieved sometimes that I don't need to think about that. And it also offers the possibility to use some multi-threading systems in Java, which is actually pretty easy to do, but you need to choose the right framework to help you out with that as a developer. So Java is already very has a nice set of features, main features for the industry, for professional applications development and web services. So if you go looking to other languages, I've done a lot of talks about Kotlin. Kotlin is now the upcoming new JVM language. Actually, they're compiling back to Java code, which makes them really strong because they're fully interoperable with Java and becoming really good at it. So it means that you can have a total hybrid application, having part of your code in Java, part of your code in Kotlin, and really, it will really work really well. So that's really powerful. However, Kotlin is also releasing their native. You can also compile back to their native machine code, bytecode. So there they are really becoming their own language, and not only running on the JVM. And what's the strength of Kotlin is that it's not only object-oriented, it also heavily leans on functional programming principles. Java tried it with Java 8 with the streaming API and stuff like that. I think it's much more natural if you look at the API of Kotlin. So there it is. It's also still typing is the same as Java, although you need less boilerplate code to specify your typing. Which brings me to the next point. It says very concise. A lot of the Kotlin language features are designed to write really clean and understandable code for everyone, which gives you the look and feel that it's very easier to maintain. So I think that's something they try to answer when we are looking into what can we do better at Java. Well, then Kotlin want to avoid a lot of boilerplate code. It's really their strong point. And then that's I think in my eyes nowadays the biggest alternative to Java in the JVM world. Then we have Scala, which I think is a bit going down popularity wise. Yeah.
Also, I think very different from what we're used to.
It's very different, yeah.
Look at Java.
It's first functional, then object-oriented. So that means that I think you need to understand mathematics if you want to understand Scala. You can really go through the language and really see it's been developed at the university, because it's sometimes goes to very abstract levels of programming, which make it in an enterprise environment difficult, I think, to lean on. But still, it has some big frameworks are still building around Scala. Think of the AK framework, think of Spark, and we can think of the performance test framework. How is it called? Gatling. So you will still encounter it, I think, in nowadays applications. So it's certainly still here. It's really strongly typed again. It's way better at pattern matching. Also multi-threaded actually. So in that regard, I think Scala was brought a lot to the JVM world, as it came really with a fresh point of view of this whole functional programming. It's also, I think, really good at writing DSL, domain-specific languages, which I think we should use more and more especially when we are writing tests and stuff like that. So those are the two main things, Kotlin and Scala, and then will come Groovy. Groovy, I think, is still used a lot at the ops part. Jenkins is all built in Groovy. So if you're developing on Jenkins, which I did a bit, then you're
used to Groovy.
You're using Groovy a lot. I won't really share my, how do you say, learnings on that point. But yeah, Groovy also is very object-oriented, but will heavily lean on closures, for instance. So you will find closures back, higher order functions. It's less stronger type. It's more dynamic kind of typing. As it has a lot of closures, it will also support domain-specific languages again, which makes it really strong for testing framework. I will think of Spock. I thought Spock was a really nice unit testing framework, but I dived into the release notes yesterday, and the last release was in 2019. I might be fading out a bit there, but I think Groovy learned a lot. Also, if you're programming Groovy, you also recognize some stuff from Python and from the C world. So it inspired itself from the other worlds in the programming world. Operator overloading is possible, which I find awesome, which is also possible in Kotlin. No, it's too powerful, right? This is totally mathematically correct. So please, people, it's possible. Let it be. Yeah. And then I will finish my whole monologue with the last one, which is quite big, I think, still, is Closure, which is a list-bonded JVM. So you really treat your code as data, and it's fully functional programming all the way. No objects. No. It's just a list-bonded JVM. So if you want to challenge yourself on the JVM, go ahead. I think it's a really nice, how do you say it? Very nice alternative to Java. It's completely different. I think this is a very valid alternative. And then you have a lot more. You have a lot more JVM languages. A lot of people designing their own language to run on a JVM.
Yeah, it's actually really funny to see the list on Wikipedia.
Yeah.
And then you're like, what?
Yeah,
is this still there?
It's just amazing. And then you have all those Java implementations of other languages like Ruby, I think you say, in Jython. You can even write PHP for the JVM. That's amazing. I was diving into that list, and then I went to, how is it called? Quarkus, which is a PHP implementation on JVM. I thought, okay, I'm not really fond of PHP, but let's dive into it. But it's really old. I didn't dare to install it on my laptop. But wow, so even that's possible.
Yeah, and also saw one for COBOL programmers. So
okay.
COBOL is also possible on the JVM if you want to.
Don't underestimated COBOL. We had a talk about it at Open Value a few weeks ago. Maybe it will come back.
And then we can just run it on your JVM.
And then you're all fine, right? So I think if you consider JVM like a choice of environment to run on, and then you just want to select one language, well, you have plenty of choice. You can do everything you want, actually. I think we can conclude that, right?
Yeah.
The JVM is perfect. You can just run whatever you want. Either it's functional programming, either it's object programming, you want static or dynamic typing, you want strongly typing, whatever you want. Agrelli typing is also possible. Whatever flavors you want in the programming world, you can just do that on the JVM, which makes it really awesome.
Yeah, and I think one also conclusion from that is most of the time it's Java and JVM, but it's not.
No,
it's just separate choices you can make.
Yeah, exactly.
You can choose the JVM because it's easy to run, for instance, for your ops guys and your architecture you have. But you can choose a language which you actually want and you like the most.
Well, you like the most, which suits the best to your problem, which suits the best of your company, of your team. People should do that more. I still don't think Java is the way to go for every solution. We should be able we should be able as programmers to be more flexible on that point and just have a look in this wide world and to see what we can do. And a lot of new languages are doing pretty well in the Java ecosystem. They do pretty well with Spring Boot. They do pretty well with all the other frameworks that you can find. So why not? Why not try them out, see whatever it happens? It's all about how you can model the problem that you're facing and which language will serve your model the best. So I think the conclusion is JVMs are awesome.
I do think so.
Yeah.
Only the favorite language maybe we can discuss about. What of those lists, and actually you can also include Java, which is your favorite?
Yeah, I still have a strong preference for Kotlin, I think, because somehow I like the syntax more. I think it's a really personal matter of taste, but and somehow I can express myself way better through Kotlin than through Java. I think the boilerplate that comes along with Java, it feels a bit awkward for me. I will go for Kotlin again. And you, what's your favorite language?
Yeah, I think at the moment it's also Kotlin.
Yeah.
Also because of the less boilerplate. I really like not typing everything, and as we already discussed in a previous one, also you can remove a lot of annotations, for instance, from Lombok, and it's all not necessary because Kotlin is it's making the getters, the setters, if you're using a data class, and it's really clear what it's going to do, and it's in their language, so you have a clear understanding what's going to happen if you use a data class, for instance, in Kotlin, and that's something I really like. But I also have to say that Java is now really accelerating in features. Yeah. And I think at some point Java will be my favorite again.
I think too, I totally agree with you on that. I think Java will get up to speed with Kotlin very fast. But I think languages as Kotlin should always exist to kick the ass of Java, right?
Yeah.
Because Kotlin is putting those features into their language, like data classes and stuff like that. They will be called records in Java 14. That's why Java is implementing them. So we really need that from the community to get Java better. But still, Kotlin is taking a good part of the market. So we'll see what the future will give to us.
So I think we talked a little bit about why are they alternative languages, and if you look to the most popular actually, or the ones you started with, they are all expanding the language, right?
Expanding by
adding new features or changing the way you should use your language, making it more functional and everything. But are there really bigger alternatives to which like use their own language and use the JVM easiness of running your application? Did you find any bigger examples of those things? Because that's the second why are there alternative JVMs?
No, actually, no. Did you find alternatives to that?
No. I think those are sticking to their own way of deploying them. Like you have C, you have alternatives for the C language, but the most programs which are made in C are not using JVM. They have their own solution of compiling and running their application on different architectures. I think that's what was for me a really funny conclusion, actually, because I think there are two whys, but actually, if you look at the most of the bigger languages as alternative JVM languages are the ones who are are being different than Java is giving to the JVM.
Yeah, exactly. No, yeah, that's completely true. Yeah. No, there aren't really alternatives to the JVM, but how would you see that then? Yeah. I can't really picture something actually.
No, and that's really funny because maybe even we like the JVM because it's easy to run it. Like we started with that one, but basically the other languages also have a solution for that because there it's not a problem. That's
true. That's true. Good point. Yeah.
It's just a little bit mind-boggling for me. It really doesn't matter, but it's like, it's basically it's not a real problem on how to run your applications, or otherwise the other applications would be using maybe JVM, or is there another solution? I think it's really interesting thing.
That's the interesting part. Yeah, I agree on that.
Okay, and maybe something about the usage, because we are already talking about the bigger languages and anything.
Yeah.
I think you found some statistics about that, right?
Yeah, exactly. I found some. Actually, I was amazed because if I was thinking about how to choose a language, and I was thinking about what I would advise to a company, I would want to dive into the market shares of the languages to see what the rest of the world is doing. And there are really there are not much reports about how the JVM languages evolve. You can have a look at the GitHub repos and see which languages are used there, but I don't think that's really representative because you won't get the whole picture of the industry. Not all the enterprise applications are on GitHub, so that's not really showing the whole picture. But I found actually one report of SNCC, the security company in the Java world, say it like that. They investigated it this year, and actually they're saying that on the JVM languages in the JVM world, 87% of the applications is built with Java. 87, which is the majority, right? Yeah. But I think I would have expect more, so I was really surprised about that. And then 5% of the application is written in Kotlin. So Kotlin is the second language on the JVM nowadays. So still making my point. Kotlin is not that bad. And then I was really surprised about number 3, because number 3 is Clojure with a 2.9%, which is kind of equal with Scala, which has 2.6% of the market share, according to this report. And there was a bit 2.9 and 2.6. I think it's kind of the same figures, right? Because there's always an uncertainty range, a standard deviation there. But seeing Clojure coming in as a third language, I was really surprised because I've never heard myself of an application written in Clojure, or at least production code.
True.
But I think that's the whole point. Like, Clojure is really offering an alternative, being so much different. So if you think it that way, it's not that surprising. And then coming in 5th is then Groovy with 1.5%, and the remaining 0.6% for the listeners that are calculating are just the other languages. So I think that's interesting. Like, there are lots of languages, but the lots is only 0.6% of the market share. So I'm really interested about how this is going to evolve, right? Because not only a language bias, but we were exactly talking about the JVM and that we can run it on all the platforms, but we're also thinking of cloud solutions and stuff like that. And how is Java going to react to that, and how are other languages going to react to that? That's
true.
Yeah,
it's very interesting to see that what will be the future.
Yeah,
actually.
We should really. I don't think nowadays, if you're a Java developer only developing in Java, I think you're missing out on something. You should really dive into those other languages, because we might see more and more applications with several languages in them. Yeah.
Yeah, that's also true. And I think that's very important to look at the other languages and what they offer.
Yeah.
And maybe at that moment in time, a other language will solve your problem more easy, better. Or I think it's really important to check those other languages, and it doesn't really change a lot. Only the first part of building your whole infrastructure should be the same, right?
Exactly. So you can just have a look at it and learn from it, and it will make you realize a lot of stuff about that you won't realize if you only look into Java. So only for that point, it's a real enrichment to dive into what people thought could be done better or different in Java. So all those languages.
Yeah, that's so true. And I scribbled some things, and one thing I forgot to mention actually with the why maybe other languages aren't jumping onto the alternative JVM language or being a thing is, I think Docker is becoming more and more important.
Okay, yeah. And how does it hold in this context? So?
I think the why alternative JVM languages are developing because it's easier to deploy, but Docker is already resolving a lot of things. It's like a generic JVM. It's not a Java bytecode virtual machine, but it's a generic virtual machine. So it does. Yeah, I think you can compare it with that. I think Docker.
Yeah.
So the languages which are now generating their application for every architecture are only forced to make one for Docker. And Docker will support all the different servers, CPU architectures and everything.
Yeah.
So I think that's removing one of the whys of the languages. And that's also maybe why you don't see the other language jumping on the JVM train to have the easy deployments. I think having a different way of looking into your way of programming is actually the way to go if you want to have an alternative JVM language, which will become popular, I think.
If you can just containerize your language or your application, you're there, right? So and if I think of that, in my current assignments, we are using Java, Python, I think even Scala all the way through on the same Kubernetes cluster. We don't really think about the virtual machines that are running underneath it. So you don't need those really weird solutions of Jython anymore, where actually, as you can just run everything on a Kubernetes cluster or a cloud environment. So good point there. So maybe Docker will make us discover new languages as well, actually.
Yeah, I do think so. It will actually make it easier to choose a different language because it's more generic on the platform, I think.
Yeah, for sure, and less maintenance for the ops guys. Yeah. So the whole management argument for no other languages because we will have a lot of maintenance, that doesn't hold anymore actually. No.
I think that's even as you point out a good opportunity when your manager is saying that, it's having no other languages. You can just say we can deploy it in Docker, and then it's also easy if you don't want to have a JVM language. But if you use an alternative JVM language, you can say no, it will be the same JVM, so no more maintenance.
That's true. It's completely true. But so I mean, I think still there will be some challenges, right? Because the JVM world the JVM ecosystem is a really nice comfort zone to stay into it. If you go out there and go to the Python world, then you need to learn a lot of new concepts still. So I think the challenges will still be there.
Yeah, that's so true.
But deployment-wise, you're safe.
But still, it's true. You get a lot of other things you have to tackle.
Yeah, you don't take for granted the whole ecosystem that goes along with it, because Java goes along with such an important ecosystem nowadays. It's really difficult to find an equivalent, I think, outside there. Maybe only C# will have a similar robust environment, but then I think there you are.
Yeah, so true.
Yeah, but still, you have a good point there, and I think when we're developing applications, we should think about it like that. Containers are not only are really solving that kind of a problem, which means that we can really go look elsewhere, go to see what Python is offering, for instance, or what C++ is even offering for us if we want to. So imagine having a Kubernetes cluster of application. We have one C# application running, and another Java.
Yeah. If you said that about somebody 5 years ago, it would be
no.
Yeah, go away.
Go away. Oh man, it almost sounds like a challenge. You just want to make that happen.
Yeah, and then I think that we're almost at the end of the podcast,
already.
And I think it's a very nice conclusion, maybe for me of this podcast, is just check the other languages and what do they offer, and
exactly
and a lot of languages which support other features which are very nice, or maybe you dislike it, but you will learn on the way, right?
Yeah, exactly. And it's not only languages do really propose new features. It's not only improvements of Java, but if you have a look at the Kotlin coroutines, for instance, which are really brand new, Java doesn't have an equivalent yet. If you have a look at Scala, you also find really very powerful features that you won't see in Java. So in Scala. So really think of the problem you're facing, think about how you want to model it, and then go look for the language that will suit you best in your application. If you have made the right choice, everyone will jump on your train because it will feel natural to learn that language, I think.
Yeah, I totally agree.
Yeah.
And I think we can now...
I can still talk about it, but we need to wrap it up. We need to wrap it up. Yeah. No. So that's the end of this JVM languages.
Yeah, and I think thanks for listening to our podcast, and hope to see you on the next. Hope you will listen to our next one, right?
Yeah, the next one is 10th episodes, I think.
Yeah.
So that's a nice number.
Yeah, maybe there will be something special.
Maybe. We won't reveal anything.
So, yeah, hope to see you next time.
Yeah, see you next time.